Well, you're back, folks. We're in the middle of Chapter 2, and we're going to talk about more graphs and displays this time. We talked about frequency distributions the last time and some of the graphs. And next time, we'll actually get started on a bit more of the numbers. That's exciting. But in the meantime, let's wrap up graphs and displays. I want to make sure my cursor is, there we go, we can write. Here are some of the things we're going to do: stem and leaf displays or plots, dot plots, pie charts, Pareto charts, scatter plots, time series charts. All really handy things to use when you're trying to explain what the data represents. Here's a stem and leaf plot. Now, just for your information, of course, this is the stem and those are the leaves. Typically, the leaves represent the last digit in your piece of data. So, for example, if we look at this right here, the 3 is a stem, so it came from 3, and the 0 is the leaf, so the 0 belongs there. That's where this particular piece of data came from, a 30. And we can see it over here. So if we want 45, 4 is the stem, so we're here. 5 is the leaf, which puts us here. And one of the nice things about stem and leaf plots is not only does it give you sort of a semi-bar chart, but it also shows you what the original data is. So if you lost this group right here, but had this display or this plot, you would still have all the data. Very handy. It's like a histogram. Has the original data values, fantastic, and it's an easy way to sort the data too, because in this stem you've got all the 20s, here you've got all the 30s, here you've got all the 40s. All you have to do is organize the leaves and you've got them all sorted. Here's another data set for us to look at, and this has 50 cell phone users. We want to display that in a stem and leaf plot. And of course, at the end, describe any patterns. So here we go. The data entries go from 17, which is right there, all the way up to 148. So this is the minimum, and there's the maximum. We're going to use the rightmost digit as the leaf. So, for example, in this one, the leaf is going to be the 8, the last digit to the right. And the 14 will be the stem. It's that easy, really. And you just fill things in. And what you want to do, though, is when you do that stem and leaf, you want to make sure that those pieces to the left, show you again, those pieces in here, you need to have them spaced exactly the same the whole way so you can see the picture. Okay. So for example, the 76. There we go. 7, it's a tens digit. It goes so there's a stem, and the 6 is the units digit, which is what we usually use for the leaf, and that gives us our 7-6. That's one piece of our stem and leaf plot. The 104, this 4 becomes a leaf, the rest of it becomes part of the stem. Of course, you usually only have one stem for each set of 10 or 20 or whatever you've got, but you'll get used to that. So list the stems all the way from 7 to 14 on the left, and then put a vertical line after them. For each one, you have the stem, and you put the leaf to the right. Here's what it looks like. So, for example, this represents 17 we talked about earlier, the minimum. This one represents the 18. If we jump down here, this represents the 55. And you can see we've got these spaced exactly the same from top to bottom. That way, we actually get a picture that we can draw some inferences from. Just for example, this one, the 50%, are between 20 and 50. And your eyes will do a lot of that work. So, what patterns? Well, here's the whole thing. Notice that we can see that there's a big chunk up here. That's important. You can see that we've got one stem leaf plot clear down here, a long distance from the main group. That tells us something about all the data as a whole. Now on this one, it did something a little bit different. Instead of having just one stem for the 10s, they had two. And they split it into, this top one is for 0 to 4 leaves, and the bottom one is for the 5 to 9 leaves. This gives you just a different look for your picture. And you have to decide whether you think one like this with double stems works better, or whether the single ones do. Very similar to that is the dot plot. And for this one, you need room on this axis, sort of like a number line. You have to make sure that all your data will fit in here. So if 21 is your first one, you have to have 21 somewhere on the left, and the largest one is 45. You've got to make sure there's room for that on the right. You probably don't want too much extra on the right and on the left, because that will make your dot plot look a little bit strange, and you won't be able to see patterns quite as easily. So let's organize that with the data set that we had a minute ago. Take those data. Now we had everything from 17 up to 148. So 17 has to show up here on your number line, and there has to be room for 148. Not too much left out here, not too much left out here. We don't want to waste space either. And that gives us a picture of what the data looks like. Looking at that, you can see that a lot of the data is in here. A different group over here, perhaps. They might be different somehow. And then, of course, we've got this strange one over here, which we'll call eventually an outlier. Don't forget, it's a good thing to pause every once in a while if you want to read more that's on the screen, or maybe you want to back up and listen to what I said, or start over again because you're a little bit short on understanding on something. Here are two examples we can use. We can use a stat program called Minitab. I used that once for my classes. It worked okay. And some instructors use something called StatCrunch that comes with their book. Either way, you can get dot plots with each of those. Next, the pie chart. You're familiar with those. It gives you a way of representing each of these parts as percentages for the i's. You divide the circle into sectors that represent categories. This is good for categorical data or qualitative data. Each sector is proportional to the frequency of each category. So, for example, the frequency divided by n, that gives you the relative frequency. And if you want to make it into a pie chart, multiply that by 360 degrees, and you know how far that this section here goes, for example. Let's look at another example. We've got numbers of earned degrees. And notice also that, where's my, there we go. Okay. Notice that this data is nominal. There's no, well, it depends on how you look at it, I guess. I guess you could call this ordinal data because not only is it nominal, but there really is an order to this too. Associate's degree is found first, then you earn your bachelor's degree, master's, and if you go far enough, you get your doctoral degree. Over here, you've got numbers. And of course, it's nominal, it's ordinal, obviously, because they're numbers. 3, it's interval because you can find differences, and that makes sense. It's also a ratio because you can say one of these could be twice as big as the other one. And 0 would mean none. None of that degree. Just a little bit of a review. So make the pie chart using the central angle. So multiply 360 degrees by the relative frequency. I just showed you that. So for example, the central angle for associate's degree is, and right here is the relative frequency. Multiply that by 360 degrees, and this is how big we're going to make the section for the associate's degree. And then we'll follow that up with the other ones, and we'll have a nice pie chart. So here's our pie chart. Looks pretty nice. Now, to be honest, you probably are unlikely to do this manually very often. Most likely you'll use Excel or some statistical program. Check that using the technology. Here they use Excel or something else because it's quite easy. And you also have the choice. Not only can you put the name there, but you can also have it put the percentages there too. So you've got a number of other things to look at one time. And you can draw conclusions from that. Next, the Pareto chart. Now this is a bar chart, number 1, and it's vertical. What sets it apart from other bar charts is that regardless of what the categories are, we put the one with the greatest frequency first. And each other category comes in order of its degree of frequency, from highest to lowest, high to low. That's a Pareto chart. Where's my marker? There we go. That's the Pareto chart, and that's how you pronounce it. So how about this one? Could you make this one into a Pareto chart? Why don't you pause and see if you can do it? Just a rough one. It doesn't have to look nice. We're not going to show it to anyone. First of all, you have to figure out which is the largest. So this is going to be the first bar. This will be the second bar. This will be the third bar, the fourth bar, and the fifth bar. Remember, they're vertical bars. So get a picture that looks something like this. So right away, the reason for this Pareto chart is right away you notice which one is most important. Or in this case, maybe there are two that are of highest importance. So if you're in the legislature, for example, and you are going to fund some research perhaps, maybe most of the money will go toward heart disease and cancer. And maybe stroke won't get quite as much because the Pareto chart tells you it's not quite as important as the other ones in some ways. Paired data sets. And we're going to get back to this in Chapter 9 where we're talking about paired data. In other words, we're talking about ordered pairs. Remember your algebra? That gives us a point. We've got x's on the bottom, y's going up vertically, and each one of these has an x and a y coordinate. And you can actually do this on your calculator too. You can put the numbers in. Now if you go to Stat, Edit, you're going to be able to put the numbers into, for example, put the x's in list 1 maybe, and the y's in list 2. You don't have to, but that's just a simple way of looking at it. And then you can tell the calculator, okay, I want you to plot a scatter plot, and then tell it where to find those numbers, and you get a picture, something like this. And that gives you an idea of how the x's and the y's are related to each other. That's a scatter plot. And by the way, when you get to setting up your plot, the scatter plot will be the first one on the list because you can make line charts and box charts and so on. Scatter plot's the first one. Now here's a big number, or a big name, excuse me. Ronald Fisher. If there's anyone who is really important in statistics, it probably is Ronald Fisher. He did a lot of work. You might find it interesting. Just spend 15 minutes and Google Ronald Fisher and learn a little bit about him. He worked with flowers and petal lengths and petal widths, and to see how they're connected to each other or related to each other. As the petal length increases, what happens to the width? So get a picture in your mind. Petal lengths. You've got these petals, and you've got lengths. How long is that one? And related to that, how wide is that one? Is there a connection between the two, or does there seem to be a relationship? And there's a picture that Ronald Fisher got. And this gives us an idea that as the petal length increases, the width also increases. Excuse me. Next, time series. And this is another plotting deal. And for time series, you always put time on the x-axis or the horizontal axis. Keep that in mind. And whatever quantitative data you've got associated with it goes on the vertical axis. And connect your x and y points, and you have a time series chart going from this time to this time to this time, and so on to the end of your data at least. Now here's one for motor vehicle thefts. We've got all kinds of examples. I hope you won't get bored with the examples because they are quite different from one to the other. Now here we've got going from 2009 to 2019. One thing you won't want to do is, if you've got a year, suppose 2012 and 2013 were consecutive years, you want to make sure every year is included. That way, if there's 0 for a year, still included. That way you can get the true picture of how things are changing over time. Horizontal axis for years, or days, or seconds, whatever it is, and the vertical axis for the numbers. Connect those with a line segment, and there you've got your time series chart. Notice the times down here, this time in years. It could be in months, could be in anything really. And up here, these are the numbers, and since we don't want to make this in millions, we can separate them and call each one thousands. And that's it, folks. Next time we get to a little bit more of the numbers. So if you are a number geek, just hold on. We'll be back with you in no time. See you soon. Bye-bye.